Hello, everyone. So my name is Elizabeth Joseph, and I'm here to give a presentation and a workshop that will be hands-on, so get ready for that, going over some Linux fundamentals, and then we're going to go into a little bit of AI. Now, the organization that I work in is IBM Z and Linux One. So everything that you'll be doing during this workshop will be on an IBM Linux One mainframe. So that's going to be exciting for folks who have not had experience with that. And I do want to let you know, at the end, I'm going to give you just sort of a brief overview of some of the tooling available for AI, which is this, the cherry on top for this presentation. But right after this session, an hour from now, my colleagues Alex and Bruce are going to be giving a hands-on workshop related to actually using a Jupyter Notebook with some of the tooling. And you will use the same VM that you set up during this presentation in theirs as well. So if you get started with this presentation and get your VM up and running, you're going to be ahead of the game for the next presentation. So be sure to stick around for that if that's something you're interested in. So I wanted to give this presentation because I am a Linux site reliability engineer by training and by trade. So I spent about 15 years doing that as my full-time job. I got into Linux, it was almost 25 years ago now. And I have a real passion for Linux and getting people involved with Linux and making people feel comfortable with the platform. Because I remember a time when I started out, I was very intimidated by the command line. I didn't quite understand what SSH was. So there were just concepts that I over the years, I've enjoyed explaining to people and getting people familiar with that so they don't cringe when they get to the command line or feel uncomfortable navigating the system that they're working on. So I spent most of my career working on distributed systems. So I started out at a tech services provider in Philadelphia. I moved out to the Bay Area about 15 years ago. I worked for HP for a time. I've been heavily involved in the Ubuntu project, and when I was at HP, I worked on the OpenStack project. And I really love this stuff. And then in my free time, I wrote a couple of books. So I've been involved in open source and the Linux, ecosystem for a very long time. I've also given presentations all over the world. This picture here under this presentations one that was a few years ago in Barcelona, where I was giving a keynote at the OpenStack Summit. So I do a lot of this, and I hope you enjoy. So basically today what we're going to go over, we're going to be using a Linux One virtual machine to go over some Linux basics. We're going to start right at the very beginning from logging in, loading up a VM and logging into it. So once we do that, I'm going to pause for a few minutes to get everyone logged in. It sometimes takes about 5 minutes for the VMs to start up. So we're going to get those loaded up and then we're going to move on with the commands. And then, as I mentioned, the final component is AI on Linux. So what I want you all to do right now is this link here, ibm.biz/linuxfun25. If you go to that URL, there is a text file in there, and I'm actually going to bring that up right now. So this is the URL. It is a GitHub repository that I created. It has the slide deck that I'm presenting right now as a PDF. You can grab that now or whenever if you'd like it. But the thing I really want you to open up right now is this linuxfun25.txt. This has all the commands that we're going to work through in this workshop. And it also has the links that you're going to need to log in to register for a VM. So the most important thing I'm going to tell you right off the bat, use this event code devday25. That will get you a VM that has enough resources to run this workshop, which is fairly straightforward. You don't need a lot of resources. But the one an hour from now, that one needs more resources. So if you use this event code, you'll be all set for the workshop that's coming up. So please use that event code when you sign up. So what I'm just going to get you ready now. So let's see, before I get into the rest of the presentation. So what I'm going to have you do, open up that text file and then go to this form and fill out the form. Again, the event code goes down here. in this event code field. If you want to start getting set up with that, I'm just going to pause for a few seconds to let people get set up. The event code also associates you with this event, which helps us understand who like how many people signed up for the event, which is nice. Okay. So while you're signing up for that, I'm going to give you a little bit of background, just in case you came into this session and are like, what is Linux 1? I thought this were just Linux fundamentals. So the good news is Linux fundamentals are Linux fundamentals everywhere. There's basic things that I'm going to cover in this tutorial that are going to be used in any Linux environment you are involved with, whether it's a big mainframe like a Linux 1 or a little embedded system with a very simple shell. Some of the commands may differ slightly, but effectively the way you navigate the file system, the way you explore Linux is going to be the same regardless of where you're running it, which is really helpful because that means once you learn these fundamentals, they're exportable to a variety of environments. But 5-6 years ago, I joined IBM to work on mainframes, and it's been a fascinating ride. So I'm going to tell you a little bit about them now. So first off, this is what they look like. This is a single frame IBM Z in the blue, and then a single frame Linux 1 in the orange. So the blue one can run all of the mainframe operating systems. You got ZVM, ZOS, ZVSE, and then of course Linux, and a bunch of other ones as well. So the blue one, the IBM Z, it's like your multi-purpose machine. It can do all the things. The orange one, the Linux one, that is a Linux only machine. And that one we launched, this is the 5th iteration. So this is the Linux 1.5. And so we've been releasing the Linux only mainframe for over a decade now, which is really exciting for me to see. And it's one of the things that brought me to the platform. Because again, I spent my whole career working on Linux distributed systems. And so moving to mainframe was a whole interesting move for me, but I was like, wow, IBM is so committed to Linux that they create an entire machine and put the word Linux 1 on it. Now, these are the single frame versions, but over here on this little diagram I have here, we have the 4-frame version. So this is like a fully decked out Z17. So you've got a bunch of IO drawers, which hold PCIe cards, which do all kinds of things. They do things like you can have like, that's where your the hardware security module is going to be. That's where the new Spire AI card is going to be. And then all kinds of things to connect to storage, connect to different types of networking. And all of that is in your IO drawers. That's why we have a whole lot of them in these machines. And then you have the CPC drawer. The CPC drawer is where your memory and your CPUs are. And I can show you a picture of one of those in a moment. Those are really cool. So the CPC drawers, they are, that's what they hold. So in a fully loaded system, you could have like 4 of those, which is quite a lot. And then down here, if you grab the slides, these are a couple of blog posts I wrote because these machines just got released like a month and a half ago. They just went GA. We shipped the first ones last week. And then they were announced like a month before that. So these are like hot off the assembly line. These are brand new systems. And I got really into it. I was really excited about these launches. So I wrote a couple of blog posts that get into the details and then also explore some more information if you're interested in them. So I'm going to pause this presentation one more time. So hopefully you've logged into the community cloud at this point. I'm going to log in as well. All right, so hopefully you've gotten the email and you were able to log into the platform. If you're still catching up after filling up that form, no worries, take your time to catch up. What you're gonna do, I'm gonna make this a little bit bigger here so you can see this a bit better. Hopefully that's better. You're gonna go here, so this guide, this was linked in the text file I sent you. So this is the technical resources we have for deploying your server. The one thing that's going to be really important here is there is a section all the way down here about SSHing into logging into your Linux One virtual server. So we have instructions for Mac OS, we have instructions for Windows. So just know that once you get to this space, you'll just have to follow the instructions for your specific operating system. Now, what I'm going to have you do is go to Manage Instances, because again, it takes a couple minutes for these systems to launch. So what we're going to do is you are going to go to Create. And actually, I'm going to make this a little bit smaller because now it's a little bit hard for me to read. You're going to first fill out the instance name. It can be whatever you want, just no spaces. This is what your machine is going to be called. I'm just going to call mine Dev Days. You're going to select the RHEL 9.3. This is Red Hat Enterprise Linux 9.3. Now you're going to scroll down to select a flavor. There should only be one flavor in there. And then you're going to go to create an SSH key pair. I'm going to just call this EKG, my initials, create a new key pair. Now this downloaded ekg.pem file. So that file, we're going to use that when we log into the machine. And I will show that once we get to that stage. But what I wanted to do right now is I wanted to get us launching this VM. So when we get to that step in a few minutes, you will be ready. So, and then you're gonna hit create. I'm not gonna hit create because I already have one ready. Because I wanted to be ready here today. Okay. So once you hit create, it'll show up here. It'll say it's I think it says it's creating the VM. And once the VM is up, you'll get an IP. It'll show it's active, and then it'll show an IP address here. So, all right, back to the presentation here. All right. So that's what's inside one of these machines. The really interesting thing also is like this is a diagram of the this one here is the inside the CPU. So it's got 8 cores. It's got these really interesting caching service cache that we've re-architected lately. It has an AI accelerator, which is really cool. This is the Telum 2. We had a Telum 1 that was released with the last mainframe version. The Telum 2 has a redesigned cache and a new AI accelerator inside the CPU. So this allows you to do really fast inferencing work, which I'll talk about a little bit towards the end of the presentation. As promised, this is the CPC drawer up at the top. So these lines of cards here, that's all your memory. And then these things with the big tubes attached to them, that is your liquid-cooled CPUs. Seeing these in person is really, really cool. So if you get the opportunity ever, I highly recommend it. It's so much fun. And then down here on the bottom here is a Spire AI accelerator. So that uses the same technology that's on the CPU and just adds a whole bunch of them to a single PCIe card that is then put into the back of the machine. And then you can extend your AI inferencing power, which was something that clients requested. So like, it's great that you have it on the CPU, but I want like a lot more of that on a whole card. So really cool technology happening in these machines and just so much AI stuff. So here we are, starting with our workshop. Again, here's the link to the workshop materials. It's going to be on all the slides moving forward. So if you missed that earlier in the presentation, or if you get disconnected or lose the URL, that's where it is. Here it is. So again, we're having you sign up for the IBM Linux One Community Cloud using the event code DevDay25. And then following the instructions to launch a Red Hat 9.3 virtual machine. And my hope is that most of us are all the way there. Okay, so you can check on your screen again and see if your machine is running yet. Mine is there running, yay, as it was before. So, I gave you, so that was just sort of basic introduction to the Linux One in general. As far as Linux is concerned, as you may know, the first Linux kernel was released in 1999. So it has been around for quite a long time at this point. Linux itself is a kernel, which is a piece of software that interacts with hardware and then puts things up to, utility land that users can interact with. So there was a kernel, and then there was all these tools called GNU tools, which are things like moving files and manipulating files. And there's a whole tool set that was developed in the 80s that the Linux kernel said, like, oh great, I can just use this existing userland tool set. So they came together to create Linux, the operating system, which some people call GNU Linux because it used the GNU tools for the user interface components. I sort of started playing around with Linux like 1999, but that was really kind of early days. That was also when people started hacking on it for the first time to run on a mainframe. So we saw the first patches from the community and from IBM in the late 1990s. I think it was like 98 or 99 when the first patches were submitted to the Linux kernel to support the mainframe. But truly, the prominence of Linux really came into its own in the sort of 2000s. And today, Linux is the most popular operating system in the world. And that is because it powers Android. It powers my little watch that I have over here. I was joking the other day that, we were sitting at dinner with some friends, and I was like, like my Linux friends from back in the day. And I'm like, could you believe that 20 years ago that would be sitting on a table with just like a bunch of Linux machines on our table in the form of our phones. On the server side, and when you're talking about other things, you may have heard of Red Hat Enterprise Linux, SUSE Linux Enterprise Server, Ubuntu, Arch Linux, Debian, Fedora. And effectively what a distribution is just like back in the day when they combined kernel and GNU. These take the Linux kernel and then also add a graphical user interface. There's default tooling and default packages that come with these default software suites. And then it's just kind of whatever the distribution wants to aim at, they include those packages for their users already. And then behind that, they also have a vast repository of software that you can install, which I'll show you an example of. And then what distribution you use really depends on what you're doing with it and your own preference. I have friends who swear by using Arch Linux. I happen to be an Ubuntu user at home and a Red Hat user at work. This laptop I'm presenting from is my work Red Hat system. I spent a lot of time working in Debian community too. I love the Fedora project. So it really depends on what your preference is. So, all right, I'm going to have you go back here and we're going to try to log into your server. So again, as I mentioned, depending on your system, whether you're using Mac or Windows, you have specific instructions here. Again, this link is in the text file in that repository of workshop materials. So again, if you're using a Mac, you want to change the ownership of the PEM file, and then you want to log in with the user Linux one. If you're on Windows, let me just open this PDF. There is a piece of software called PuTTY that can allow you to log in to a remote server. So you can grab PuTTY at this link here at the top, and that just downloads the software. And then this walks you through adding the key to the loading up a private key, which is that PEM file, and then using it to log into the machine. So again, I will leave that up to you over the next few minutes, whichever system you're on. In Linux, we have this thing called an SSH directory. So my file is going to be in here. So I'm just going to log into the system here. So my key pair. And then I'm going to get my IP address. So on Linux, and this is going to be very similar to Mac. Oops, I'm using the wrong key. I think it might actually be Well, that's fun. Oh, sorry about this. Turns out I've already logged into a VM with this IP address. I think that means I launched too many of these VMs. All right, so it's going to ask you to verify the authenticity of the fingerprint. You just type the word yes, not just Y. You have to type YES. And then you're going to get logged into your Linux One system. Now, again, this is a server that exists over at a university in New York. And so you just traverse the internet to find this server. Okay. So back to the presentation. Yeah, so there's lots of distributions out there. For this tutorial, as I said, we launched a Red Hat Enterprise 9.3 server. So we're going to do some exploring there. Again, all the instructions are going to be in that workshop documents. So if you get lost along the way, or I'm going too fast, or you just want to watch and play around later, that's fine. You can do that too. But I'm going to get started. So just have my terminal here, and I'm going to go through some commands. And again, I forgot to mention, this Linux One Community Cloud, you have it for 60 days. So you can play around with it for a while. After 60 days, you will get an email allowing you to renew it for another 60 days. So you could have it for a total of 120 days if you want to play around with it. This is for community use. So if you have a project you want to test out, or just, install some services, have some fun. Don't do bad things, because we do keep track of what people are doing on these machines, and we will shut it down if you break the terms of service. But have fun and explore, and just enjoy your access to this. I will make this a tiny bit bigger. Actually, I'm going to keep it back the way it was. Okay. All right. So you are in your home directory. Right now, there is not anything here. But if you find yourself in a different place in your world, you can type the cd command, or you can type the cd tilde command, which I have here. Tilde just means home directory. But what we're going to do is and cd is how you move around. So if you do cd tab, you can go into what is cd www, what's in, or no, cd var. Now I'm moving around the file system, and you can see things in what's in this variable directory. But if I type cd, I'm going to get back home. So what I'm going to do in my home directory, I'm going to do this command called mkdir, mkdir, test. So now when I do ls, you have a test directory there. What you can do is you can then use cd again to go into your directory. So I have done cd test. And we do have tab completion. This is the bash shell, which I do automatically now. So, but anyway, you don't need to type out test. You could just say like cd t and then tab, and then it'll complete based on what's in the shell. So what we're going to do is we're just going to create a couple files. So I'm just going to call. So you can use the command touch, and that will create a file. So you can do ls again. So now we're going to create file 1, create file 2. And these are just empty text files. They don't have anything in them. So then you can also ls file 1. That just is. But if you do more something like ls al, that gives you some information about the file. So all these letters over here, this means it's readable and writable by my user. It's readable by everyone on the system. Just that's how it is. And then it's owned by the Linux One user, which is the one, again, we logged in with SSH using the Linux One user. The file is 0 bytes because it's just an empty file that we just touched. Now, say you're using cd, you're moving around your file system, and you get lost. You can type the command pwd, and that tells you where you are on the file system. So you are in your Linux One home directory in your test directory. If you say, oh, I didn't mean to create file 1, you can remove file 1. And now all you have is file 2. Now, another thing I'm going to have you do, we're going to cd into slash. Now, slash is the top level file system. So you saw here, this is like home Linux. These are just Home is one of the things you have under here. So I'm going to do ASL, and this is going to show you everything under here. So again, we were in your home directory, but now we are at the top level of the file system. And there's all kinds of things here, but I wanted to just quickly give you a tour of some of the common ones. So I'm going to move this over here and show you here. I have descriptions of a bunch of this stuff. So we've got bin, like /bin, which is like, it's right here. It's actually soft linked to user bin. It's a thing that Red Hat does. So bin is where programs live. So applications that you install on your system, they will be in the bin file. So when I do a command like ls, I can type the command which ls, and that will tell me that it's in user bin ls. And it also tells me a little bit of information about the defaults of the command. So it shows you it's in the bin directory. The etc directory has system-wide configuration files. So these are files that configure things like users and applications that you end up installing. We're going to install Apache in a little bit, which is a web server, and there's configuration for that in etc. Home, you've already been there. That's where you keep your own files, and that's where you log into when you log into the server through SSH. Lib is short for library. That's sort of like shared libraries that are shared between applications. So that's like shared libraries that every applications from all over your system may access those libraries. Opt is one that you run into quite quickly, I find, when you're starting to use Linux. That is where optional packages are installed. So if you have a package that comes not from your Linux distribution, they may say install it in the opt directory. So sure, let's do that. Root is your administrative user. You don't log into that one very often, but that one has full power over the system. You, as the Linux One user, have full power as well, but you have to use the sudo command. So that sort of allows you to become root temporarily if you're using it without any options. So the root has a home directory too, and that is /root. User, USR directory, that's shared read-only files. It can also include some binaries. So again, we saw user bin is actually what bin is alias to on this machine. And then the last one I want to share is var. That's variable files. This is usually where you'll find your system logs, things like printer spools and mail caches, all this stuff that's like data that's coming and going and being manipulated a lot. As a result, some people put var on a different partition that maybe be like faster disks or something, just because there's so many reads and writes to var constantly. I mean, these machines are just logging stuff all the time. All right, so the next screen of more commands here. So if you forget which Linux distribution you installed on your system, you can run the command cat etc release. This will work on Red Hat, Ubuntu, and SUSE, so whichever one you installed in the Linux One Community Cloud, it'll show a response. So in this case, we are using Red Hat Enterprise Linux 9.3. This is really interesting too, because you can look at this release file when you're writing applications, so you can learn what environment you're on, and then your application can behave in different ways depending on, like, maybe Red Hat has a different version of software than SUSE has. So on SUSE, you may want to make just different choices in your application. So this is where you can find that information. I mentioned that we're on a Linux One mainframe. So if you do lscpu, this gives you information about your CPU. So it is the architecture S390X, that is the architecture of Linux One and IBM Z. It is 64-bit. It's big endian. It's one of the only big endian platforms left. Most platforms that you're going to interact with are little endian, and that's just about the byte order of memory. Vendor ID, we're IBM. We have machine type information and just a whole bunch of stuff. These are flags on the CPU. We are running the hypervisor that's beneath this. We're running on ZVM. That's interesting to know. You can also run on KVM. You can run directly on your LPAR. There's all kinds, but in this case, this environment runs on ZVM, which we can see from inside the system. So that's pretty cool. If you find you're running out of space, you can say, hey, you can run the df command and see how much space. So I am not running out of space. This is my root, again, that slash there. This shows me I'm only using 4% of my disk so far. So yay. that storage. If you ever wonder what you're running on your system, you can run this command psaux. And if you make this screen a little bigger, I'm going to run that again. And you can see all this stuff's running. So I've got SSH stuff's running, systemd, which is the thing that controls some of the services on the system, network manager, which handles my networking. So all these default applications are already running on my system. So that's how you see those. It also gives you the ID of them. So if you ever need to kill a process ID, if you ever need to do something with the process ID, it shows up in this output. You can, and if you ever need to clear your screen, you can type the word clear. But as you've been seeing, I have been using a shortcut. I use Control L to clear my screen because I have muscle memory for that. If you ever need to know the date, hey, date and time right there. I am, and this is showing it in Central Time, which is interesting. And then you have things like lsmod, which just tells you the modules that are loaded into the kernel. And these tend to be for hardware support or different types of support that you want to load for your interaction with things that you're using on the system. If you're curious about your IP address, you can type this command IP and then adder. I like to use ipnfc adder because that makes it colorful. And now I can pick out. So 127.0.0.1, that is home. That is yourself. If you ping that, you are pinging yourself. If you've ever seen a joke like there's no place like 207.0.0.1, now you understand the joke. It's home. But here is your public IP. In some systems, like this isn't going to be universal. In these systems, we do expose the public IP to the virtual machine. If your virtual machine is behind a firewall or you're doing this at home on a VM, this may be a 192.168 number, which is an internal IP address. So that's not externally accessible. But in this case, on these systems, that is your public IP address. So that is the IP address you logged into. Now, the IP command can do lots of stuff. So if you're curious about what your command can do, you can type the word man, which is short for manual, and let's say IP. And this has a bunch of on-system documentation. So there are man pages for most commands that you can think of. Oftentimes you can do help as well. So this gives you just like a shortcut of like basic commands on how to use it. And again, like if you're curious about ls, like there's a man page for ls. ls also has a help. And so there's lots of stuff here for you to get help on the system. Or you just do what we all do and just go to Google to try to figure out what you want to do. All right. The next thing we're going to do is we are going to install some software and then edit a test file. So what I'm going to do, so look at where am I? I'm pwd. Where am I? Oh, I'm in my root file system. So I'm just going to go home. There's no reason for me to go home right now, but I want to make sure you're in the right directory for the third command on this page. I'm going to make my screen a little bit smaller again so you can see this. Okay. So first thing we're going to do, we're going to run the sudo command. I remember what I said about sudo. It gives you root privileges on the system. So you are administrator when you use sudo in this context. Sudo is an extremely versatile thing. So you can use sudo to switch to a user. Sudo doesn't always have to give full permission to the system. Sometimes sudo can be used to give you specific controls, like you can have a user can be set up to only have administrative privileges for running certain commands. So sudo it's my favorite and least favorite tool in the Linux tool belt, because a lot of people misunderstand it. They think it's for super user, but it's actually just it's a limited subset, or it could be everything on the system. But anyway, so DNF is what Red Hat uses. It's a package management system or package manager tool. It reaches out to the repository of software that exists on the internet. So what I'm going to do, I'm just going to install a editor called Nano. It's probably the easiest one you can use on this system. I use Vim because I've been using Linux for 1,000 years. So anyway, what we do, you just sudo dnf install nano, and this says, yes, I found the nano package built for your architecture. This is the version. Do you want to install it? I'm going to say yes, just with the Y, and it just went out to the internet and grabbed the nano package. So now I can run Nano. So what we're going to do, run Nano, and then again, test, and then we still have file 2 in there. So file 2 is the one that we touched earlier. Now, this is your file. So you can say, hi, this is my file. Type whatever you want in there. And then to exit, you can just do Control X and then save modified buffer, which is what you just wrote. You're going to say yes. And then you can just hit enter because it's going to just save it to the file. Okay, now, do I have stuff in that file? How do I check? What you can do is you can use the command cat to see the contents of that file, and that just outputs it to your terminal there. You can also open up the file again and see that the text is there. Okay. All right, next up. We are going to build a website together. So again, we are going to use DNF install. So what you can do, again, sudo dnf install httpd. HTTPD is an alias on Red Hat for the default web server. And on Red Hat today, the default web server is Apache. And so what it does here, it says installing HTTPD, which is what I asked it to do. It's also installing dependencies, and these are applications that are supporting the Apache web server. So there's a bunch of stuff that you need in order to install HTTPD. So I'm like, okay, looks like I need all these. It's also installing weak dependencies. So these are ones that you might not necessarily need, but most users do. So they're going to install them. You do have the option of not installing the weak dependencies if you want a slimmer system, but in this case, it's fine just to install everything. It's only, we're downloading like 3 megs of stuff, so it's very simple. So there we go. We have installed Apache. Now what we're going to do is we're going to set this up to start. We have to start the Apache web server because it did not start. We're also going to enable it. Now enable means that the next time you reboot the system, if you ever reboot the system, the Apache web server will come up again for you, which is nice. So now it just created a symlink in systemd, so now it launches it when the system starts. Now, did those commands work? Let's find out. We can write status in this command, and look at that. Apache web server is active and running. So what I'm going to have you do is edit another file. So this time we're going to use sudo because the file that we're going to edit is under the variable directory. And this is just the default index file, the default website file. So do sudo nano, and then we're going to do var www html index.html. All right, this is an empty file. So what are we going to put in here? So you can put whatever you want in here, but I'm going to copy this text here. Oops. Actually, let me go to my text file that you all have as well. And I have different text in this text file. So I'm going to copy this text, and then I'm just going to paste it into Nano. Okay. And then I'm going to do, again, Control X, and then yes to save, and then enter to save it in that spot. Okay, that's cool. So I made some website. I made a website file. The next thing we're going to do is we're going to open the firewall, because by default on these machines, we've locked everything down because these are in a shared environment and they're publicly accessible. So what we're going to do here, again, I'm going to go back to my instructions in this text file so I can copy this because it's a long command. So it's saying IP tables, which is your firewall. It's going to accept input from your TCP port 80. And you know what? That's a little odd. Okay, so you know what? I think when I copied this, I may have put a space in there or something. So that probably is my problem. So when you copy this, just type the word accept if you run into trouble. I don't know why that didn't work right. Anyway, so it did work this time. Now what I'm going to have you do is open up a web browser now that we've opened up the firewall, and take your IP address again and paste it into your URL hey, that's my website I just created. So this is a lot of fun. Play with this as much as you want. You can have your little website running for 120 days if you want, but it's a lot of fun. I have a WordPress tutorial as well on the. I think it's in this technical resources. I was actually in the process. Oh yeah, LampStack. I'm in the process of updating this because I ran into some problems with Red Hat specifically and SE Linux. But if you want to play around with this later, install a more complicated website, you're free to do so. So cool, you just made a website, yay. All right, now we're gonna have some real fun. I mean, that was real fun. We're gonna have some more real fun. We're gonna install Tetris, and we're gonna build it from source, because Red Hat Enterprise Linux, it doesn't come with games because it's made for grown-ups. So I mean, the market for Red Hat Enterprise Linux is enterprises. So in their main repositories, they don't have games. So what we're gonna do, we're gonna install some tooling to do some development. So we're gonna install Makefile and GCC. So Make is a tooling for, GCC is for compiling, and Make gives the compiler the instructions on what to do. So yes, I'm going to install this stuff. Sorry if there's a little noise in the background there. And then what I'm going to do, I'm going to go back to my thing here. So this is a tar.gz file that is just a compressed file. We're going to use the command curl, which will download it from the internet. And don't worry, you're like, Liz, you're just having me download random stuff from the internet. This is just an open source GitHub project. It just open source Tetris. I've been using this for a while now. This is just, it is just an application written by someone I don't know. So that's the wonder of open source. He wrote a Tetris file, and now I'm using it for this demo. So the next thing we're going to do is we are going to use the command tar. So tar is an archive command, so you can use it to put files together and compress them. In this case, the commands I'm using are to decompress the file. So this decompresses it, and I'm going to cd into that. And again, you can use tab completion, so you don't have to type out all those numbers. And this is what you just downloaded. So we're going to type this command configure. And that ran so fast. I was like, what happened? So that ran configure. So that just like sets up things for the compiler. And then you type make to actually compile the software. And if you ever want to make a movie, this is what you can put on the screen for when people are hacking things. It's just very impressive. Like, I don't know what happened. What happened there? GCC did its thing. It looks very, very technical and very fancy. But hey, you compiled some software. That's cool, right? Okay. Now what we're going to do is we're going to run dot slash will execute a binary. So what we did there is we created a binary. This doesn't live in your bin file, but you can go and put it there. But for now, we're just going to run it right here. And this loads up Tetris. So I'm just going to do the easiest stuff. I'm just going to do a one-player game, level 0. And now you can play Tetris on a mainframe, which is cool, right? So you just use your arrow keys to move this around, and you can go back and play with this whenever you want. So you can do Q to quit, and that just brings you back to your terminal. All right. So that was fun. All right, so we are coming to a conclusion here for the Linux component. So go ahead and play with this as much as you like. There are other things you can download and compile and just play around with the system. Again, you've got 120 days if you extend your trial to do what you want. So if this was interesting to you, there are other resources out there for learning more about Linux. There's tons out there, honestly, but I just picked out a few that were interesting to me. There is a hands-on introduction to Linux commands and shell scripting. So shell scripting is just automating things and writing little programs written in the shell, like the Bash language or something. Just it's quite a simple scripting language, but it helps you learn more about the system and automate things a bit more. But it does give you more introduction to Linux commands beyond what I showed you here. This is my favorite. Number two here is my favorite book. It's from 2017, but a lot of the fundamentals are still there. And when I was learning Linux, I think I was using the second or third edition of this book, the Unix and Linux Systems Administration Handbook, and it was pink. And so I'd call it the pink book. And everyone at our Linux users group back in the day was like, we all have the pink book. Like, just look it up in the pink book. So it's such a good handbook, and it's written by some really, really smart funny people. So it's great if you want to pick that up. Even you can even pick up an older edition from a used bookstore. It's probably going to be fine. We also have, as I mentioned, actually it's the IBM Linux One Community Cloud Fast Start Guides. These are ones that we wrote specifically for this environment, and they go over various things you might want to install. I think we've got one for Nginx. We also have an OpenShift environment that you can try out. I think that one's a 2-week trial. And some of the fast start guides are there, but these are just tutorials that you can go through to learn more. And generally, this is a Linux One VM, but if you find a Linux tutorial online somewhere, most of them are going to work. So just give it a try and play around with things as much as you like. And then my fourth one I strongly recommend is just, start a project and learn along the way. That's what I did. I mean, I started with Linux on my desktop a very long time ago, and it was fun to play around with. But then I was like, I want to make a website. How do I do that? And so I learned how to install Apache. I learned how to, install PHP. I learned how to enable modules. And for me, having a goal was what really helped me learn the system, because it gave me a reason to go through and learn all of these pieces along the way. So feel free to start a project and learn more about Linux that way. Okay. The last thing I wanted to quickly touch upon in this presentation is AI on IBM Linux One, because one, it's really important in the industry today. A lot of people are working on AI. Being familiar with AI and machine learning concepts are really important. Two, Linux is basically the premier platform for AI these days, and the applications that you're running on Linux are going to be important to know about. And three, it's really fun. I started doing AI training a few years ago, and just getting into it and learning how to create models and spit out contents and see, how it matches reality or not. It's just a really fascinating space to be in. And it's really exciting. There are so many tools out there today that make it really easy to do AI as a beginner. And if you find it hard, don't be put off by the fact that I said it's really easy. It's not easy. The concepts you need to learn, but the on-ramp and the documentation and the communities out there, they're there to support you and help make it easy for you. So there's just so many resources out there. The first one I want to mention is TensorFlow. It's an end-to-end platform that makes it easy for you to build and deploy machine learning models. So there's learning materials and really great tutorials on the TensorFlow website. We also have this ibm.github.io AI on Z 101 page that gives you a lot of context on how TensorFlow is used in a Linux One environment specifically, which is interesting. And I have one of these links for every one of these projects I'm going to talk about quickly here. Next one is PyTorch. That is machine learning framework in Python. That basically, it's used a lot. I mean, this underlies a ton of projects. It is used in research. It is used in production. It is used all over the place in the machine learning space. Again, they have some really great tutorials on their website. And then we have a page on our AI on Z 101 GitHub repository about PyTorch and how it's used in our environment. Another thing I wanted to mention is Onyx. Onyx is a form, it's a shared format that allows you to take models and then apply them on various frameworks or compilers. And in the context of Linux One, this allows your model that you've trained to run on the Linux One processor and take advantage of that AI accelerator that I talked about. So if you're interested more in Onyx, there's an introduction link here. And then again, the IBM Deep Learning Compiler is Onyx based. So I can show you that in a moment, but we have, we explain that all on this website. The other thing I want to mention are, once you get into the inferencing mode, so you've trained your model, maybe you trained it on Linux One, maybe you've trained it somewhere else. The Triton Inference Server and SnapML, they help, SnapML does training as well, but these are what you can use to actually run the inferencing. So in the world of AI, you've got training, which you put a ton of data and create a model. And then inferencing is taking that model and actually applying it against real world data. So you give your model lots of information about what fraudulent transactions look like at a bank. And then once that model looks really good, you throw real bank transactions on it and see what it shows up and say like, yeah, now it's detecting fraud because it already has been trained on this. Now we're actually running it against real transactions and giving responses. So that's what inference is. So it's inferring things from the model that you've trained. Again, we've got some links here, and then these go out to the open source projects. So these are both, everything I'm showing you here, all open source. So the Triton inference server, that's open source, SnapML, all open source. Now, I kind of mentioned on building and training and deploying. So this kind of shows you can use a bunch of open source projects and tooling to train your model. You dump it into ONNX or the IBM Deep Learning Compiler, and that's what goes into your CPU to leverage all that. And then beyond that, you can just over here under applications and languages, there's just this whole world that you can use, once you're managing your model. So that's fun. And then the last thing I want to talk about real quick is the IBM Z Deep Learning Compiler. So as I said, you create your model after you've built and trained it, export it to ONNX. It goes into the Deep Learning Compiler and creates that library, which you then put into the inference program and then can run on your Linux on Z system. So that's where you do the inferencing. So last big thing here. If you want to learn more about AI on Linux One, there is a product page, but it's actually quite good. I don't send people to IBM product pages a ton, but our product pages over the years, if you haven't been to one in a while, they've gotten a lot better and a lot more technical. So we're getting better there. So this Journey to AI on IBM Z and Linux One product page, it goes out into a lot of documentation and read books and a lot of interesting things about AI on the platform. You will note, since I said IBM Z, there will be some things that are for ZOS and some things that are for Linux on Z. You just want to be careful. If you're focused on Linux, just follow the links that are talking about Linux One and Linux on Z. Otherwise, you might find yourself in ZOS space, which is a lovely place, but maybe not what you're looking for. But just keep that in mind as you're looking at AI tooling. Some of them are for ZOS, some of them are for Linux. There is a red paper, which is kind of like a short book developed by folks at IBM on enriching Linux on IBM Z workloads with AI. And that sort of walks you through taking workloads that you're already running and adding some AI flavor and also the tooling available, which I talked about. Number 3 here is the documentation that I already pointed you to. I like to say this is written by a bunch of geeks inside of IBM, so that's why it's on GitHub. It's totally true. I give them updates all the time. Be like, oh yeah, we should update this. And then, as I mentioned in the beginning of the session, up next in 7 minutes is another workshop, and this one is AI on IBM Z and Linux One, hands-on experience. So you'll use the VM that you created here, and then you get to launch a Jupyter Notebook, and you can interact with that during the next workshop. So if you have some time to stick around, I highly recommend that. And you'll be ahead of the game if you already got your VM launched. And that is all I've got. So I'm going to exit my share here and see if we have any questions. All right. Looks like some comments, lively discussion. Okay. All right. I'm going to give you a few minutes back to get ready for the next session. What do the specs look like for the Linux One share, and how are they split between users? So these are all deployed on LPAR on a mainframe, so that's a logical partition. I don't know how big the LPARs are, honestly. That's maintained by another team. But they are, I think, with the VM that we brought up, Let me just look at the memory. I think we've got 6 gigs of memory on these systems that we give to you for this tutorial. So we've got 6 gigs of memory. Memory is shared, and I think CPUs are our user base, so we do give you like a virtual CPU, and then memory is shared across users, and then your hard drive is like dedicated to you. So we give you 50 gigs of space to play around with, 6 gigs of RAM. In this specific one, when you use that event code, we give you a slightly bigger VM so you could do our machine learning demos. And then I was just going to look at the CPUs again. We give you, looks like 2 CPUs. No, one VPC. All right. How would you use Linux tools to debug and optimize a slow-running AI inference service on a cloud instance? Ooh, that is a big question. I would start with the tooling built into the inference service, because there will already be a lot of information inside of that. So you would first start to see if the service is running because the service is overloaded specifically. You then can look, if you think the service is running fine and it may be a problem with Linux itself. These are you'd look into your Linux logs and do other you would search for just like general Linux slowness things. So you would documentation. So what you might do is search for, why is my Linux server slow? And then you would do a bunch of debugging command. And that uses things like the PS command that I showed you before. There's also a top command, which can show you what is using the most resources. And you can sort that once it's running by memory or by CPU. And that will allow you to see what's taking up a lot of CPU. It may be a network connection problem. So there's a lot of networking tools. IP just scratches the surface. We also have a bunch of TCP programs on the Linux system. So there's a whole world of tooling out there for debugging various things. So it's not even directly related to the inference server, but I'd start with the inference service itself and see what is built into that to see about slowness. Next question is GPUs. So on a Linux one, we do not have GPUs today. We do training using, we have the AI accelerator, which does, in addition to doing really fast inferencing, it does make training faster than just using general CPUs, but they are not GPUs in the traditional sense. The event code was dev day 25, which Holly may have shared. All right, thank you for coming, everyone. If you have any questions or got stuck anywhere in the tutorial, my email address is on that last slide. I can have Holly send it over to you. It's liz@ibm.com, and I'm happy to help people out. Or if you have questions after the event, feel free to reach out by email, and I will get to you as soon as I can.